So here is the third question of this series. The question is how many real numbers satisfying the equation mod of x minus 4 plus x minus 7 equals to 15. And the options are 1, 2, 3 or infinitely many. So let's start. Okay, so for this we have to know the modulus function. Okay, what is modulus function? As we know that the modulus function acts like uh, if we give any input, then if we give any positive numbers as an input, then it gives us the same number, and if we give a negative number as an input, it gives us the positive values. So we know that this, but the thing is we have to um, know the definition also. So the definition is if x greater or equal to 0, then mod x gives us x, and if x less than 0, that is for the negative values. So what what will be the operation? Suppose I give the negative value, it gives us minus of that negative value to give us the positive one. So the mod x equals to minus x if x less than 0. Okay, so it is the basic definitions of mod x. Now we are going to find out the solution. So let's just write down the given equation. Mod x minus 4 plus mod x minus 7 equals to 15. So we have to find out the real numbers for which it satisfies the equation. Now let's consider this function uh, y equals to mod x minus 4 plus mod x minus 7 minus 15. So, and the requirement is if we find out the real numbers alpha for which y alpha equals to 0, then we are done. Because if y alpha equal to 0, then alpha also satisfies this equation, right? So our main aim is to find out the alpha for which y alpha equals to 0. Now one more thing, suppose y equals to fx is a curve, is any curve. So to find out alphas, and if we draw the coordinate graph, say like this, so let's suppose it is the coordinate, it is the function of fx. It is actually function of fx, and we can draw the graph on our coordinate axis. Now uh, these points, consider these points, say a, b, c, d, e. In this point we can see that it cuts the x-axis. So we can say that y equal to 0, yb equal to 0, and so on, ye equal to 0. So to find out the zeros of this function, if we can see the number of points for which this curve cuts the x-axis, then we are done. So we try to find out those alpha belongs to real numbers for which uh, x equals to the y, this function actually cuts the x-axis at x equals to alpha. Okay, now we are breaking this function, we are breaking this function into three equal parts. Suppose it is 4 and it is 7. So we consider three regions. Okay, one region is x less than 4, that is this portion, and another is x greater than 7, that is this portion, and the last one is 4 less than x less than 7. So we'll break this function into three region, and we'll check um what is the functions to act like. Okay, so we considered a new slide. Let's just uh, write it down. If x less than 4, then what will happen? X minus 4. If x less than 4, then actually x lies in this region. So x minus 4 is negative. So x minus 4 is negative. So suppose so if x less than 4, then mod x minus 4 is negative. X minus 4 is a negative number, so it gives us minus x minus 4, because as we can see that mod x equals to minus x when the value is less than 0. So it gives us minus x plus 4. Similarly, in this region, mod of x minus 7 will give us minus of x minus 7, as 7 lies here. So x less than 4 implies x less than 7 also, and it is a negative number. So minus x plus 7, it will give us minus x plus 7. So yx would be mod x minus 4 plus mod x minus 7 minus 15, that is minus x plus 4 uh, minus x plus 7, that is here, and minus 15. So together we get minus 2x, 4 plus 7 11, minus 15 plus 11, that is minus 4. So yx would be minus 2x minus 4 if x less than 4. Suppose, so for this region, suppose 4 is here, for this region yx acts like minus 2x minus 4. Okay, let's move to the next region. So we consider another another region, 4 less than x less than 7. So 4 actually, so x lies between 4 and 7, so for which we can see that mod x minus 4 would be, so x minus 4 itself a positive number because x is greater than 4, so it gives us only x minus 4 as it is positive. But x minus 7, if x lies here, then x is negative and 7 is x is less than 7, so x minus 7 would be negative, and for which it gives us minus x plus 7. So yx would be x minus 4 minus x plus 7 minus 15, that is x and minus x will cancel out, and minus 4 minus 15, that is minus 19, plus 7 minus 12. So for this region, yx acts like a constant function, that is minus 12. Okay, suppose, and the last one, that is we consider the region x greater than 7. So at this region we can say that x minus 7 equals to x minus 7, as well as x minus 4 equals to mod of x minus 4 equal to x minus 4, as x is greater than 7 also and x is greater than 4 also. So it is both are positive numbers, so it will gives us the same according to the a mod function. So yx would be x minus 7 plus x minus 4 minus 15, that is 2x minus 7 plus 4, that is minus 11, minus 15, that is minus 26. So in this region, yx would be 2x minus 26. So if we combine all the three, then we would get, suppose it is our x-axis, suppose it is 4, and there is 7. So in this region, yx would be minus 12. See here, yx equals to minus 12. So we draw, this is a minus 12, it's a constant graph, and in this region, for x less than 4, it acts like a yx equals to, for less than 4, minus 2x minus 4. So it will be minus 2x minus 4. And see that if x equal to minus 2, then y equal to 0. So it touch this point x equal to minus 2 at y-axis. So and it is a straight line. We can see that it is a straight line. So the curve would be like joining this 2 point, and it will goes to plus infinity when x less than minus 2. So it never bent down to cut the x-axis again. And similarly for this region, y equals to actually minus 2x minus 26. So for this region, minus 2x minus 26. And we can see that if x equal to 13, hold on, it would be, sorry, plus 2x minus 26. So it is plus 2x minus 26, and if we put x equal to 13, then we get y equal to 0. So it cuts the x-axis at x equal to 13. So the straight line would be like this way. So we draw the y. It is actually the function of y, and we can see that it cuts the x-axis at 2 points. That is y of minus 2 equal to 0 and y of 13 equal to 0. So we are getting 2 points for which yx equals to 0. So these 2 points actually satisfies the equation, the given equation. So how many real numbers are there satisfying this equation? How many real numbers are there? There are only 2 real numbers, that is 13 and minus 2. So the correct option would be only 2. It is the solution. Now, one more thing I must mention here. Suppose, suppose for this type of question, if it is given like this, how many real numbers satisfying x minus alpha plus x minus beta plus x minus gamma, sorry, mod of x minus gamma equals to some r. So for this, what we'll have to do, we have to consider alpha point, beta point, and gamma point on the x-axis, and then we have to consider these regions individually and try to find out the functions. And whenever the function cuts the x-axis, we get that number as a solution of this, and we can count them and as well as um, get the solution also. Okay, so That's all for today, and stay tuned.